So now we'll be looking at linear inequalities in two variables. And what does this mean? Here we have a linear function, but now we have two variables. Like in the examples we've been discussing before, we only had one variable and that was just x. But in this case, we're going to be having two variables, x and y, in the inequalities. So before, we used number lines to represent the inequalities because we had one variable, but now we're going to represent them in the Cartesian plane because we are making use of two variables, x and y, but the dynamics is still pretty much the same. So what is the Cartesian plane? The Cartesian plane, also known as the xy plane, is just a plane that shows, or a normal graph in which you have the x-axis and the y-axis. It's a two-dimensional plane that shows the relationship between ranges of values of x and ranges of value of y. And I'm pretty sure that you have come across this when you are trying to use the graph. So these are what we are going to be using now to represent inequalities that have two variables. So the convention that we're going to be using is the shaded region in the plane is going to show what we want, or is going to show what we want to identify. So the other convention that is available is to use the shaded region to show the point that is not required, but we're not going to be making use of that convention here. So how do we represent inequalities on the Cartesian plane? So first, we are going to start with one variable. So here we just have one variable in which you have x greater than 3. If it were to be on the number line, what we'll do is we just draw a number line like we have been discussing before, and we just locate where 3 is. And what do? Greater than 3, so we just put an arrow pointing towards that direction and we'll put what? X greater than 3. But now, to represent this on the Cartesian plane, what we do is first we draw our Cartesian plane, or we just quickly draw a sketch of it like I will do right here now, and we label the axis. So here we have our x-axis and here we have our y-axis. And in our x-axis now, I have 1, 2 and 3. I'm told that the value of x is greater than 3. So what I will do is that I will draw a line that cuts through 3, a vertical line that cuts through 3. And now I'm going to make use of dotted line because I have strict inequality. If it were to be an inequality and an equals to sign, then I'll use both lines. But now I'm just going to make use of dotted line. So that is also the convention to use. So when I draw it across the desired point, which is x equals to 3, I'm told that the value of x is greater than 3. So since it's greater than 3, that means it lies to the right of 3. So what would I do? I'll just shade this region. So I'm just going to just shade this region. So this region that I've shaded over here represents what? The value of x greater than 3. So anything that lies in this shaded region represents x greater than 3. Let's look at another example. So how would I represent y greater than or equals to minus 2? So what we do is we first sketch out our Cartesian plane, and when we do that, try to identify or locate the axis. We have the x-axis over here, and we have the y-axis over here, and we have our y as what? 1, 2 on, and here we have what? The y-axis minus 1, minus 2, minus 3. So we are told that the value of y is greater than minus 2. So where does minus 2 lie? Minus 2 lies here. So we'll draw an horizontal line to cut through minus 2. So we are told that the value lies above minus 2. So that means it lies above. So what do? I use the bold line now because I have greater than or equals to sign. So I use a bold line to cut through the 2. Then I shade the upper region because this is the region that is greater, for which y is greater than minus 2. Then I have to label. So I have what? Y greater than or equals to minus 2. So now let's try to combine two variables on the Cartesian plane. So for example, now I might be told to show the points for which these two expressions are satisfied. So the procedure is simple. So what do I have to do? First, I need to identify those points on the Cartesian plane. And so to do that, like we have done before, the first one tells me that what? X is greater than 3. So I look for the value of 3, and where does it lie on the x-axis? This is my 1, and this is my 2, and this is my 3. So now, since it's a greater than sign, let me use another marker to indicate. I'm going to have what? Use dotted line to cross through that point. So what do I have? I have what? A dotted line crossing to the 3, and I'm told that the value of x is what? Greater than 3. So that value lies in this region. So I have the value of x greater than 3 lying in this region like we've done before. So I have what? X greater than 3. Now for the other region, I'm told that y is greater than or equals to -2. So I look for that point and let me make use of a different marker. So I have what? -1 here, and I have -2 here. So now my x is greater than or equals to -2. Since it's greater than or equals to -2, I made use of what? Both lines. So I draw it like this, and I'm told that what? I have the value of y being greater than or equals to -2. So I shade the region that lies above that point. So when I shade it, so this region above represents what? Y being greater than or equals to -2. So what region satisfies both conditions? So the region that satisfies both conditions are the region in which the red line and the green line intersect each other. So now that region is clearly identified as this region over here. So this region over here, where the green line and the blue line, the green line and the red line intersect one another, is the region in which these two conditions are being satisfied. So I should mention now that to locate the region in which two or more inequalities being satisfied, you just have to draw those inequalities on the Cartesian plane, then you just locate the point in which the shaded region intersects. Then that is the region that you're looking for. So let's try to solve a practical example. So now we have an expression in which we have what? Two variables. We have two variables, x and y. So now if you look at this critically, you know that this is synonymous to an equation of a straight line. And if you don't know what this is, you try to look up the module on equation of the straight line to have a brief idea of what it's all about. So how do we represent, say, this inequality that has two variables on the Cartesian plane? So the way we go about it is by following these simple procedures. First, we make y the subject of formula. So to make y the subject of formula, we know that y will be what? Y will be less than 3 minus 2x. So we have made y the subject of formula. So, and that gives us that what? Y is less than 3 minus 2x. So now we assume that the equation of the line is equals to y is equals to 3 minus 2x. So we just change the inequality sign to an equal to sign temporarily, and we try to locate the coordinates at x equals to 0 and y equals to 0. Why are we doing this? We are doing this so that we can locate 2 points on the line. So when we locate 2 points on the line, we can just connect those two lines to graph out the line. So to do this, we say when x equals to 0, what is the value of y? So when x equals to 0, what is the value of y? So I know that my y is equals to 3 minus 2, and my x now is 0. So I have my y is equals to 3. So when x is equals to 0, the value of my y is what? 3. And these are the coordinates written in brackets. So we'll do the second condition, that when what? Y is equals to 0, what is the value of x? So I know that my y is equals to 3 minus 2x. So I substitute the value of y as 0. So I have 0 is equals to 3 minus 2x. So I have what? 2x is equals to 3. And if I divide both sides by 2, I have what? My x value being equals to what? 3 over 2. So the second coordinates that I've gotten from here is what? My x value is 3, 2, and my y coordinate is what? 0. So what do we do now? With these two coordinates, we sketch out the graph and we shade the required region. So let's move on to the next page to do that. So I'm going to write out the important results that we have gotten. So first, the question tells us that what? Tells us that 2x plus y is less than 3, and to make y the subject of formula, we've written that y is less than 3 minus 2x. Now we have gotten the two coordinates as what? 0, 3 and what? 3 over 2, 0. So we need to locate this on the Cartesian plane. So what do? We sketch it out first and foremost, and we try to locate those points on the Cartesian plane. So now for our x-axis here and our y-axis, for our x-axis we label, we have what 1, 2, 3, 4, and for our y-axis we have what 1, 2, 3. I'm just going to label the positive axis because the numbers here are just positive. So for the first point, I have when x is 0, y is 3. So when x is 0, the value of y is 3. So I shade this point. And the second condition, I'm giving that when x is 3/2, my value of y is 0. So when x is 3/2, 3/2 is the same thing as 1.5. So when x is 3/2 lies at this point, the value of y is 0. So I have this point. So what do? I join those 2 points together. Now what do I use to join those 2 points together? Let me change the marker color to red. So now to join those points together, now since I have just a strict inequality sign, I'm going to make use of what dotted lines I've explained before. So I join those two lines together like this, and from the when I made y the subject of formula, I add what that y is less than this. So what does it mean? Y is less than, so that means y lies below this line. Assuming it was y greater than, it means y will lie above the line. So in this case, the region that I'm looking for is region in which y is less than or y lies below the line. So this inequality will be given by all the lines that are within this region that is below the line. So this region below the line, we have what 2x plus y as less than 3. Now let's move on to another example. We are told to represent this point on the Cartesian plane. We are given that y minus 2x is greater than or equal to 2. So our first procedure is to make y the subject of formula. So we have y is greater than or equals to 2 plus 2x. Then we change the inequality to an equal to sign temporarily. So we have y is equal to 2 plus 2x. So we try to sketch out the graph of this. So we do that by finding the coordinates when x and y are 0. So when x equals to 0, what is the value of y? The value of y will be given as 2 plus 2 into bracket 0, which will be equals to 2. So now what happens when y is 0? So when y is equals to 0, the value of x will be given as 0 is equals to 2 plus 2x. So we have what? Minus 2x is equals to 2. If I divide both sides by minus 2, I have what? X is equals to minus 1. So my first coordinate will be given as what? 0, 2, and my second coordinate will be given as my x value here is minus 1, and my y value here is what? My y value here is 0. So now what do? I sketch out on the graph on the Cartesian plane. So I just draw this down like over here, and I have this right over here. So what would this be? So my x-axis and my y-axis, I try to locate the point. So my x-axis, I have 1, 2, then I have minus 1, minus 2. My y-axis, I have 1, 2, and I have minus 1, minus 2. So for my first point, I have when x is 0, my y value is 2. So when x is 0, my y value is what? Is 2. And for my second point, when x is minus 1, my y value is 0. When x is minus 1, my y value is 0. So I have these 2 points. So what do? I need to join these 2 points. And now that I have weak inequality of greater than or equals to, I make use of what? Bold lines. So I just make use of bold lines to join these 2 parts together. So now the question tells me that y minus 2x is greater than or equals to 2. So now that we have greater than or equals to, or y is greater than this, what does this mean? It means that the value of y lie above this line. So now the value that lie above this line are every point that lies upwards of this line, which indicates all these lines above here. So here, what do I have? All this shaded region above represents what? Y minus 2x greater than or equals to 2. So how do we combine when we have 2 inequalities and we are told to find the region that satisfies both inequalities? So that is what this example 3 is going to be all about. So now we are told to show on the graph the region that satisfies these 2 inequalities. And if you would observe, we have already solved for this initially, and we've solved for this initial also. So for the first one, what are the important results that we got for this 2x plus y less than 3? What we made y the subject of formula, we got y to be less than 3 minus 2x, and we got the coordinates to be what? To be 0, 3 and 3 over 2, 0. Now for this second inequalities that we just finished solving, in which we have minus 2x greater than or equals to, when we made y the subject of formula, we got y greater than 2 plus what? 2x. And for the coordinates, what did we get? We got 0 and 2, and we got minus 1 and 0. So we got what? 0 and 2, 0, 2, and we got what? Minus 1, 0. So we'll try to locate these 2 points now on the Cartesian graph. So to start with, we have to draw our axis. So here now we have this. So on the x-axis we have what? 1, 2, 3. On minus 1, minus 2, minus 3. And the vertical axis we have 1, 2, 3. We have minus 1, minus 2, minus 3. So let's try to sketch out the first one using a red pen. So we are trying to do this now. So here we have that what? 0, 3. So when x is 0, y is 3. When x is 0, my y value is 3. And when x is 3 over 2, my y value is 0. When x is what? 3 over 2, which is somewhere around here, my y value is 0. So now I have just less than to what? I just have this dotted line because of the strict inequality, just less than, and I have my y value less than. So this point will lie what? Underneath this line. So every point that lie underneath this line is represented as what? Is represented as what? As 2x plus y is less than 3. So let's move on to the other one now, and I'll use a green pen for that. So I have what? 0, 2. So when x is 0, my y value is 2, which is somewhere here. And when x is minus 1, my y value is 0. So when x is what? Minus 1 over here, my y value is what? 0. So I have this over here. So now since I have less greater than or equals to, I make use of both lines. So I make use of both lines to connect these two lines together. And now I'm told that the value of x is what? Is greater than or equals to. So what does it mean? It means that what? It lies above this line. So that means all the region here that lies above this line will represent that point, and which includes what? All this shaded region over here, which is what? So this shaded region over here represents y being greater than or y minus 2x being greater than or equals to 2. So the question asks us to find the region that satisfies both points. So how do we get that? We get that by looking at the place in which the red line and the green line intersect with each other. And if we look at that carefully, we can see that that lies within this region over here. This region over here is where you have the red line and the green line intersecting. So this region over here is the region that satisfies both inequality. So to recap, to find the region that satisfies both inequalities, two or more inequalities, you sketch out each of those inequalities on the Cartesian plane. Then all the region in which you have the shaded region intersecting with each other is the region that connects them together. So all you have to do is look for region in which you have overlapping of lines together, and that is the region you are looking at. So this pretty much sums up the idea of linear inequalities in two variables.